So my name is Jyrki Huttunen. I come from Oplatek, and I try to give you some info about Lidars and what we are doing in that area as an optics company. So wait a minute. Okay, doesn't move. Okay. Yep. Okay, so that's the agenda for today. Some introduction from Oplatek, of course. Something about Lidar technology, applications, then what we have been doing in Lidar design, and short summary. So something about Oplatek. So if you like to put it in short, so we are designing and manufacturing innovative photonics solutions. That's the big picture of our business. We have been in business for over 30 years already, doing this kind of stuff, optics the whole time. We had last year, for example, more than 100 I would say very satisfied, loyal customers. And this is the expertise area where we are. So all these what are listed here we have in-house. So we have a pretty nice set of technologies. We can combine them and make different kind of assemblies, devices, whatever, using those technologies. Fiber drawing, we are drawing into fiber drawing towers, different kind of fiber products, capillaries, and so on. For high power lasers, measurement systems, etc. Glass molding, different kind of freeform optics, especially lighting applications, some other applications also, measuring and things like that. Then we are making thin film coatings, so different kind of filters, changing the color of light, anti-reflection coatings, mirrors, reflectors, and so on. And we have our own workshop, so most of the metal parts what we need, plastic parts, we can machine ourselves. And we can also support our customers in design phase, so we can do optics design, prototyping, all kind of stuff for the customer if the customer wants to use our expertise. And the goal is normally to get into the assembly business so that we would build some kind of a device or assembly for our customers in big series, of course, if possible. Okay, then we have been involved in a couple of these projects, EU projects, which have been kind of targeted in developing autonomous driving. Matti already told the big picture about the situation there, and VTT has been a big player in these both projects. The DENS on the right hand side is the one which includes more kind of a real hardware development, and I will shortly describe a little bit that what we have been doing in that project. So about the technology in general. So somebody has said that it's a breakthrough technology for 3D mapping. Remote sensing is the idea, of course, and we are measuring distance by illuminating with the laser and then detecting the reflected light, what we are getting back from the target. Laser beam is moved depending on the application. It can be 360 degrees, or it can be some narrow kind of opening if the application doesn't require more. But we are getting a pretty detailed image which has a high quality, and actually it kind of shows more than normal radar images. Those are the kind of main parts or building blocks of a Lidar. We have a source, some kind of laser, of course. We have a scanning element which is moving the laser beam. Can be mechanical, solid state, some other alternatives also exist. Then we have a detector. And actually, in lidar business, a couple of years ago, I heard that somebody had made kind of a market survey and estimated that there were, at that time, 80 different companies developing their own kind of lidars. And most of those companies were some kind of startups. So this is kind of a very hot topic still in the business. So some basic numbers. This is not any specific lidar. These are kind of rough numbers which indicate that what kind of accuracies or ranges or things like that we are talking about, both in sensor side and in the light source side. High peak power has to be eye safe, of course, and these operate normally wide temperature range because that's the way nature is outside. And pulse, the laser is pulsed, of course, and accuracy can be at the level of 10 centimeters at least. So a little bit about the applications. The future is automotive. That's the big kind of application which everybody believes that there will be a big business around that. At the moment, most of the business happening in geographical area and construction and industrial applications, military to some extent, of course, and robotics. But the market value in some of these market surveys has been, or market estimates has been written up to 7 billion by 2030. So this will be a really big business in the future, and most of that will be autonomous driving, according to this market study or estimate. A little bit about these markets. So when we are looking at the volumes, the military is interesting, but normally the volumes there are not that high. Geographical survey, there is already some kind of volumes. Robotics, even more. Construction and industry, even more. And the biggest clearly is the automotive market, according to these estimates which the CEO Development Market Agency has done. Okay, then something about the design work we have been doing in our company in this dense project especially. So we have moved the wavelength of the normal LiDAR, which most of these are nowadays using this around 900 nanometer range wavelength. So we have moved up to 1550 nanometers, and we have found a nice polymer which is transparent at that wavelength. So we were able to manufacture those optical parts, lenses, some other optics, what is needed there. We were able to manufacture them from plastic. And of course, when we are talking about a high volume product in the future, the price of the product is of course critical, and normally plastic optics can be manufactured cheaper than glass optics. So that is kind of an important thing. And when we are at that wavelength range, so the peak powers can be high, so we can look further, go up to hundreds of meters in autonomous driving applications where this is about. And in that picture we have a schematic of the optics, which like it is at the moment, it is not ready yet, so the project is still ongoing and it will end next summer. But this is already kind of a pretty much tested and proven that it will work. This is another picture, a little bit different point of view. So the base of these frames are missing. There are only the optical parts, how the beam is moving there. So the laser beam is narrow, of course, in the beginning when it is emitted from the laser, but when it reaches the target, the vertical opening is 16 degrees and horizontally it's 38 degrees. And we have a scanning mirror which is moving constantly the beam. So, as a summary, we think that the Lidar is now a kind of a best technology at the moment for this 3D information gathering, and the market in the future will be autonomous driving. At the moment, only this military, geographical, and construction industry are the some kind of markets at the moment. Technology today is not good enough in a way that it's too bulky, too expensive, but that will change, of course, in the future when everything is developing and when the volumes are getting bigger, then the price per piece, as normal, it's getting lower. And the market is really big. So there is lots of potential, lots of opportunities. So this was kind of a shortly about Lidar and what Oplatek has been doing in this business. So thank you.
Thank you very much.
Thank you for the presentation. I find it interesting that you seem to have gone into the direction of still of a Lidar with mechanical parts, as in the it seems to be the holy grail at the moment to develop the solid state Lidar. So do you have any how did you choose that direction and path? Can you explain a little bit?
Well, that's basically the decision of that project, which started a couple of years ago, and the idea was kind of utilize the existing Lidar and just make some modifications to that. So we didn't start from the scratch. We had this existing Lidar, and then our task, we were giving a task that, okay, check this, see how it works, move the wavelength up to 1550 and design the new optics for that. So that this is kind of it comes from that project. I know that there is lots of things happening in this solid state world, and who knows what kind of lidars there will be in the future. Maybe this kind of mechanical ones are not at all an option after a couple of years, but this was pretty much kind of we had a task and we did it like it was instructed to us.
Any other question? Because I would like to know that there is always, when you are developing the new technology, so there is always some kind of bottleneck. So what is your opinion about what is the bottleneck at the moment in LiDAR technology, so that is coming to more and more use in the practical field?
Well, in this project, the idea why did we move to 1550 nanometers was that we would get more range and better performance in difficult conditions, in rain, snowfall, in mist or dust or whatever. So that was the idea. There is, of course, that kind of a technical kind of limitations always exist, and you just have to then find a compromise which works best to kind of tackle that challenge, whatever it is, and that's what we have done in this project with this wavelength change. And then some new materials which we have found for the optics. So in general, bottlenecks in LiDAR technology, I'm not that much of an expert, really, all these different kind of technologies that are used there, that I could say that is there some specific one thing or what would be that. So unfortunately I cannot answer to that question. So. Matti might know, yeah, okay.
I don't know.
I thought that you wanted to answer.
Yes, I just wanted to respond to that one. So I think that actually we are talking about those two different projects where Jyrki was pointing out that the robustness and dense. We were not really in order to create some kind of a solid state LiDAR. I don't think that that was a key component in order to do it in this case. But why we went to that 155, the reason is that there are some scientific evidences that the scattering in that area is a bit less. But it's not really the biggest thing, because I think that the scattering is less by 2-3%, which is not the great benefit compared to 905, where you have a lot of cheap components. The reason why we went to the 155 is the eye safety. 905, you always have the limitation of the eye safety, that you have to use the class 1 laser, which means that you cannot really increase the power of that laser such much as you would like to. 155, the eye safety regulations are not so hard, so you can increase that by 100 times bigger. I think that Jyrki knows a bit more even than I do, but in any case, 100 times bigger, which means that you can really penetrate to the fog, and that was the reason in order to talk about it.